Data definition language, DDL statements, are used for creating, modifying, and removing data objects. They affect both physical and logical data structures. Their syntax generally much more varied than the data manipulation language, DML statements, we have covered in the previous 2 units on SQL. The create statement in SQL can be used to bring into being a range of different data objects, including the following: data tables, views on existing tables, indexes, data structures which speed up access to data, database user accounts. In this section, we shall concentrate on the use of the create statement for establishing new tables. The create table statement has a range of different options, and so we shall start by showing a simplified version of the syntax as follows. Where column specification includes a column name, the data type of the column, where appropriate, a specification of the length of the column, an optional indicator of whether or not the column is to contain null values. Data objects are subject to a number of restrictions, and these will vary between different database systems. We shall describe the restrictions on naming tables and columns in Oracle, as they are fairly typical, and limitations encountered in databases generally, the main exceptions to which being older PC-based database environments. Table names must start with an alphabetic character and can contain up to 30 characters. Table names can contain the letters A to Z, the number 0 to 9, and the characters dash and underscore. Table names must be unique within any specific user account. Column names must start with a character and may comprise up to 30 characters. They can contain the same characters as table names. Column names must be unique within a table, but you can specify the same column names in different tables. In Oracle, there can be up to 254 columns in a table. Referring to the simplified version of the create table statement above, the column specifications are contained in parentheses. We shall focus on 3 specific data types for use in our practical work, as their equivalents, though they may be differently named, can be found in almost any database environment. These data types appear in Oracle as the following. Varchar2 is used to store variable length character strings. In Oracle, they can store up to 2,000 characters. The syntax for specifying a data item of type varchar2 is varchar2 length, where length is the maximum length of the character string to be stored. Number is used to store general numbers. The number data type offers the greatest flexibility for storing numeric data. It accepts positive and negative integers and real numbers, and has from 1 to 38 digits of precision. The syntax for specifying the number data type is number, precision, scale, where precision is the maximum number of digits to be stored, and scale indicates number of digits to the right of the decimal point. If scale is omitted, then integer, whole numbers, are stored. Date, used to specify an attribute, is of type date. The format in which dates are represented with an attributes of type date is day, month, year, for example, 10 January 2000. The syntax to specify an attribute as of type date is simply to specify the word date after the name of the attribute in the create table statement. Like many other systems, Oracle contains a number of other data types, in addition to the most commonly found ones just described. As an example of other data types that may be provided here are a few of the rather more Oracle-specific data types available. Decimal is used to store fixed point numbers and provides compatibility with IBM's DB2 and SQL/DS systems. Float is used to store floating point numbers and provides compatibility with the ANSI float data type. Char is used to store fixed length character strings. It is most commonly used for representing attributes of one character in length. Long is used to store a little over 2 gigabytes of data. However, none of Oracle's built-in functions and operators can be used to search an attribute of type long. The final part of a column specification allows us to specify whether or not the column is to contain null values, that is, whether or not it is a mandatory column, that is, it must be given a non-null value. The syntax is simply to specify either not null or null after the data type and possible length specification. Remember that a primary key is used to identify uniquely each instance of an entity. For the music collection table, the primary key of item ID will identify uniquely each of the items in the music collection. The create table statement provides the syntax to define primary keys as follows. Create table, table name. Column specification, 1, column specification, and primary key, column A, column X. Where columns column A, column X, are the columns to be included in the primary key, separated from each other by commas, all of the columns included in the primary key being enclosed in parentheses. In SQL, the definition of a primary key on a create table statement is optional, but in practice, this is virtually always worth doing. It will help maintain the integrity of the database. Oracle will ensure all the values of a primary key are different, and will not allow a null value to be entered for a primary key. In Oracle, there is an upper limit of 16 columns that can be included within a primary key. A foreign key is used to form the link between rows stored in one table and corresponding rows in another table. For example, in the sample dataset we have used in the previous 2 units on SQL, the foreign key, empdeptno, in the employee table, was used to link employees to their corresponding departments in the DEPT table. The create table statement allows us to specify one or more foreign keys in a table as follows. Create table, table name. Column specification, 1, column specification, and primary key, column A, column X. Constraint, constraint name. Foreign key, column A, column XX. References, primary key specification. As for primary keys, foreign key specifications are not mandatory on a create table statement. But again, specifying foreign keys is desirable in maintaining the integrity of the database. Oracle will ensure that a value entered for a foreign key must either equal a value of the corresponding primary key or be null. Create table statements can contain both a primary key specification and a number of foreign key specifications. An explanation of the foreign key specification is as follows. The first item is the keyword constraint, followed by an optional constraint name. Although specifying a constraint name is optional, it is recommended that you always include it. The reason for this is that, if no constraint name is specified, Oracle will allocate one, and this will not be in any way easy to remember. If you later wish to refer to the foreign key constraint, for example, because you wish to remove it, then, providing your own name at the point you enter the create table statement will make this very much easier. The words foreign key, followed by a list of the columns to be included in the foreign key, contained in parentheses, and separated by commas. This list of column names is, in general, different from the list of column names in the primary key clause. The mandatory keyword references, which indicates that the foreign key will refer to a primary key. A primary key specification, which starts with the name of the table containing the reference primary key, and then lists the columns comprising the primary key, as usual contained in parentheses, and separated by commas. The full stops, shown in the version of the syntax above, indicate that there may be more than one foreign key specification. An extremely useful variant of the create table statement exists for copying data. Essentially, this consists of using a select statement to provide the column specifications for the table to be created, and, in addition, the data that is retrieved by the select statement is copied into the new table structure. The syntax for this form of the statement is as follows. Create table, table name. A select statement, where select statement can be any valid SQL query. This form of the create table statement can be used, for example, to copy entire tables, copy subsets of tables using the select list, and, where clause, to filter rows. Create tables which combine data from more than one table, using joins. Create tables containing aggregated data using group by. Examples of copying data using create table. Select. Example 1. To create a copy of the MP table we have used in previous exercises. SQL, create table employee copy, to a select from employee table created. Sometimes you may wish to copy the structure of a table without moving any of the data from the old table into the new one. For example, to take a copy of the structure of the employee table, but without copying any employee records into the new table, we could use SQL create table, employee structure, to a select 3 from employee, for where 1 equals 2. Table created. This is an example of the way the SQL language can be made to fit a particular purpose. We wish in this example to copy the structure of a table, but ensure no rows are selected from it. By supplying a where clause, which contains a condition, namely, where 1 equals 2, that can never be satisfied, we ensure that no rows are copied along with the structure. The alter statement in SQL, like the create statement, can be used to change a number of different types of data object, including tables, access privileges, constraints, etc. Here, we shall concentrate on its use to change the structure of tables. You can use the alter table statement to modify a table's definition. This statement changes the structure of a table, not its contents. You can use the alter table statement to add a new column to an existing table, increase or decrease the width of an existing column, change an existing column from mandatory to optional, that is, specify that it may contain nulls. Columns can be added to existing tables with this form of the alter table statement. The syntax is alter table, table name. Add column specification 1. Column specification n. For example, to add a department head attribute to the department table, we could specify SQL alter table department. 2. Add department head number 4. Table altered. We could imagine that the new department head column would contain employee number values corresponding to the employees who were the department heads of particular departments. Incidentally, if we had wished to make the department head field mandatory, we could not have done so, as the alter table statement does not enable the addition of mandatory fields to tables that already contain data. We can add a number of columns with one alter table statement. This form of the alter table statement permits changes to be made to existing column definitions. The format is alter table, table name. Modify column specification 1. Column specification n. For example, to change our copy of the employee table, called employee copy, so that the department number attribute can contain 3-digit values. SQL alter table, employee copy. 2. Modify department number 3. Table altered. This form of the alter table statement can be used to increase the length of an existing column, transform a column from mandatory to optional, that is, specify it can contain nulls, There are a number of restrictions in the use of the alter table statement for modifying columns, most of which might be guessed through a careful consideration of what is being required of the system. For example, you cannot reduce the size of an existing column, even if it has no data in it. Change a column from being optional to mandatory. Change the data type of a column. The alter table command can also be used to add and remove primary and foreign key constraints. This will be covered further in the unit on constraints and database triggers. To remove a table, the DLL statement is drop table, table name. It is deceptively easy to issue this command, and unlike most systems one encounters today, there is no prompt at all about whether you wish to proceed with the process. Dropping a table involves the removal of all the data and constraints on the table, and finally, removal of the table structure itself. Example: to remove our copy of the employee table, called employee copy. SQL drop table, employee copy. Table dropped. The insert statement is used to add rows to an existing table. The statement has two basic forms. First, to insert a single row into a table. Insert into table name, column list values. List of values to be inserted. The column list describes all of the columns into which data is to be inserted. If values are to be inserted for every column, that is, an entire row is to be added, then the column list can be omitted. The list of values to be inserted comprises the separate values of the new data items separated by commas. To insert a number of rows using a select statement. The syntax for this form of the insert statement is as follows. Insert into table name, column list, select statement. The column list is optional and is used to specify which columns are to be filled when not all the columns in the rows of the target table are to be filled. The select statement is any valid select statement. This is rather like the case of using select with a create table statement, a very powerful way of moving existing data, possibly from separate tables, into a new table. Example: supposing we have created a table called Manager, which is currently empty. To insert the numbers, names, and salaries of all the employees who are managers into the table, we would code SQL insert into Manager. Select employee number, employee name, salaries. From employee, where job equals manager. 3 rows created. The update statement is used to change the values of columns in SQL tables. It is extremely powerful, but like the drop statement we encountered earlier, it does not prompt you about whether you really wish to make the changes you have specified, and so it must be used with care. The syntax of the update statement is as follows. Update table name. Set column list equals expression subquery. Where condition. The set keyword immediately precedes the column or columns to be updated, which are specified in the column list. If there is more than one column in the list, they are separated by commas. Following the equals sign, there are two possibilities for the format of the value to be assigned. An expression can be used, which may include mathematical operations on table columns as well as constant values. If an expression is supplying the update value, then only one column can be updated. Alternatively, a subquery or select statement can be used to return the value or values to which the updated columns will be set. If a subquery is used to return the update values, then the number of columns to be updated must be the same as the number of columns in the select list of the subquery. Finally, the syntax includes a where clause, which is used to specify which rows in the target table will be updated. If this where clause is omitted, all rows in the table will be updated. The delete statement is the last of the DDL statements we shall look at in detail. It is used to remove single rows or groups of rows from a table. Its format is as follows. Delete from table name, where column list equals IN. Constant expression subquery. As for the update statement, if the where clause is omitted, all of the rows will be removed from the table. However, unlike the drop table statement, a delete statement leaves the table structure in place. Views are an extremely useful mechanism for providing users with a subset of the underlying data tables. As such, they can provide a security mechanism, or simply be used to make their users' job easier in reducing the rows and columns of irrelevant data to which users are exposed. Views are the means by which, in SQL databases, individual users are provided with a logical, tailored schema of the underlying database. Views are in effect virtual tables but appear to users in most respects the same as normal base tables. The difference is that, when a view is created, it is not stored like a base table. Its definition is simply used to recreate it for use each time it is required. In this sense, views are equivalent to stored queries. Views are created using the create view statement. The syntax of this statement is very similar to that for creating tables using a select. Example. To create a view showing the names and hire dates of employees based on the employee table. SQL create view, employee hire. As select employee name, hire date. From employee. View created. When specifying the rows and columns to be included in a view definition, we can use all of the facilities of a select statement. However, there are a number of situations in which the data in base tables cannot be updated via view. These are as follows. When the view is based on one table, but does not contain the primary key of the table. When the view is based on a join. When a view is based on a group by clause, or aggregate function, because there is no underlying row in which to place the update. Where rows might migrate in, or out of a view, as a result of the update being made. The syntax of this extremely useful command is as follows. Rename old table name to new table name. Example. To rename the employee table to new employee. SQL rename employee to new employee. Table renamed. The rename command is an extremely useful one when carrying out DDL operations. This is in part because of the shortcomings of the alter table statement, which make it necessary, sometimes, to copy a sub or superset of table, drop the former version of the table, and rename the new version to the old. For example, if we wish to remove a column from a table, it is necessary to do the following. Use the create table statement to take a copy of the old table, excluding the column which is no longer required. Drop the old copy of the table. Rename the new copy of the table to the old. SQL statements can be combined into a file and executed as a group. This is particularly useful when it is required to create a set of tables together, or use a large number of insert statements to enter rows into tables. Files containing SQL statements in this way are called SQL script files. Each separate SQL statement in the file must be terminated with a semicolon to make it run. Comments can be included in the file with the use of the rem statement. Example. Rem. The next statement inserts the forecasting databases. The word rem appears at the start of a new line in the script file. Rem statements do not require a semicolon terminator.